Hello friends, this is Sumita Gupta. Welcome you all again for the next experiment of digital electronics using virtual lab. Today we will do designing and verification of 4-bit synchronous and asynchronous counter using JK flip-flop. So let's start now. Go to the Google and as I have told you, type virtual lab or vlab.co.in, click on virtual lab, click on electronics and communication. Here, click on digital electronics lab 1 designed by IIT Roorkee. Click on list of experiments. In list of experiments, now we are doing 10th experiment. 1 to 9 we have already done. You can follow my previous videos. Okay. So this is design and verification of 4-bit synchronous asynchronous counter using GK flip-flop. Now the theory part. Now what is a counter? Counter means which counts a bits. Like 1, 2, 3, 4, 5, 6, 7, which counts a bit. The counter can be 4-bit means which can count 0 to 15. Okay, 3-bit means which can count 0 to 8, 0 to 7. Okay, so like this counter. Now, what is the difference between synchronous counter and asynchronous counter? And difference of the clock. In asynchronous counter, we use one clock, but the clock is provided at first flip flop only, and the output of the that flip flop is behave like a clock for the next flip flop. And the output of next flip-flop is behave like a clock for the third flip-flop. And for this is 4-bit example for 4-bit asynchronous counter. The output of this third flip-flop is behave like a clock for the fourth flip-flop. So means we are not providing a clock, universal clock to every flip-flop at the same time. We are providing clock for the first stage, and the rest output of these stages behave like a clock for the next stage. That is the asynchronous counter. Now, what is the need? Means the proper. If you want some delay in the output, because for the getting the clock for the any flip flop, it requires some delay. Means we are not giving clock at the same time, so this will take some delay. Okay, that is asynchronous counter. Now see that timing diagram. If you can see here, you can see here. See. The high input at JK flip-flop, if you remember at JK flip-flop, if for 1, 1, the output is toggle. Means if it is 0, then it will be 1. If it is 1, then it will be 0. Means output toggles. Okay. So for first flip-flop, we have provided the clock. Means at every clock means this output will be toggle. And we have already given 1, 1. Okay. 1, 1. High is 1, 1. And this 1, 1 is given at every flip-flop at the same time. 1, 1. Okay, so now concept is the output will be toggle with the clock. So the first stage output toggle with this clock, second stage output toggle with this clock, means with the Q0, and third stage output toggle with this clock means with Q1, and the fourth stage output toggle with this clock means Q2. Okay, means because JK is already 1, 1 at all the flip flops, JK is already 1, 1 because high input is provided for every flip flop. So 1, 1 here, 1, 1 here, 1, 1 here. So output will toggle, but depends on the clock when it's getting the clock. So see, this is a clock. Now first stage, this is Q0. Now see, for this falling edge of this clock, this is toggle from 0 to 1. So where is the falling? This falling, this falling, this falling, this falling. So at every falling edge, okay, this is toggle. Toggle means 1 to 0, 0 to 1. And this falling edge, now it is 1, it will become 0. At next falling edge, now it is 0, it becomes 1. Okay, at every falling edge, it's 1, 0, 1, 0, 1. Okay, that is the concept of Q0. Now we'll talk about the Q1. Q1 will already inputs are 1, 1 high. Means output toggle, but clock. Clock means this Q0. So when Q0 is having falling edge, okay, when Q0 is falling at this point, so it toggles now here from 0 to 1. Next, it is falling in here, so 1 to 0. Next, falling is, this is 1 to 0, so toggle 0 to 1. Next falling, 1 to 0. Next falling edge, 0 to 1. Because for this, this is the clock. For Q1, this is the clock. For Q0, this was the clock. But for Q1, Q0 is the clock. Okay. Now next is for Q2. For Q2, Q1 is the clock. Inputs are already 1, 1. So it will toggle, but according to clock Q1. So this is Q1. Now this is the falling edge. Now here it will toggle from 0 to 1. Here it will toggle from 1 to 0, 0 to 1, 1 to 0. That is for Q2. Now for Q3, Well, very good. Point this Q2. Q2 is a clock. The Q2 has falling edge here. So here it will is 0 to 1. Here 2 0. This is 4-bit counter means so the all the combinations see here 0 0 0 0 0 is 0 0 0 1 0 0 1 0. Okay. Now 0 1 0 0 0 1 0 0. So if we will check the last is 1 1 1 1 0 to 15 means you will get the table like this 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1. See here 0 0 1 1 then 0 1 0 0 0 1 0 0 and last will be this all one. It will count from 0 to 15 because it's a 4-bit counter. 4-bit counter means 2 raised to 4. 2 raised to 4 is 16. So we'll start from 0 to 15. So this is asynchronous counter. So what is the concept? Remember, this is counter is of JK flip flop. So JK flip flop 1 1 and output toggles with a clock. So 1 1 at the same time high input is given to the all the flip flop. So at 1 1 it output toggles, but output toggle with respect to clock. So but here clock is given at first input only, and for next stage the output of previous stage is the clock. That is asynchronous counter. Okay. Now we'll see synchronous counter. Now difference between asynchronous counter and synchronous counter is of clock. Here clock is given at the same time. Here clock is given at the same time. See here, this is a clock. Clock is given at the same time to every flip flop. So you don't have to wait for the output of like in this previous case. The first stage output was behaved like a clock for the second stage, but here it is not the case. Here already clock is given to every flip flop at the same time. So that is a big difference. That is a big difference in asynchronous and synchronous counter. In synchronous counter, clock is given, a universal clock is given to all the flip flop at the same time. But in asynchronous counter only, clock is given to a first stage only. Okay, so there will be no delay. So synchronous counter faster than the asynchronous counter. Now, but the thing is here, this high input is given at the first stage only. The high input because output toggles when J or K and 1 1. So this is given at here only. Okay, so now clock is there, but this output toggle whenever this JK1, whenever this JK1. Now, so the Q naught is connected as an input of this second flip flop. So in the previous case, output of first stage was the clock of next stage, but in this case, output of first stage is the input of next stage. It's the input of next stage. Okay, the output of first stage is the input of the next stage, J and K. Okay, so whenever this output is 1, then only it will toggle. When this output is 1, then only it toggle. So ultimately, you get a timing, this timing diagram same, but how to realize this is the flip flop. Okay, so directly connected. This is the first second stage. Now come to the third stage. The third stage, Q1 is not the input of the third stage. Q1 and Q naught. So AND gate is required. Means when both inputs, both outputs 1, 1, 1, then only AND gate output 1. Then you will get 1, 1. Then only it will toggle. The concept is it will toggle whenever J is K and 1, 1. J and K 1, 1. So for this, the previous all the output should be 1 because it's connected with the two previous output. Now come to the last stage. Here also we want J and K 1, 1 for toggling. So here all the three outputs Q0, Q1, Q0 are multiplied. Means all three outputs 1, then only it is 1. See here, it is connected with Q2 and connected with the output of first AND gate. First AND gate output is already Q1, Q0. So all three are multiplied. Q2, Q1, Q0. Okay. Again, listen. This is already 1, 1, but we want 1, 1 here also, 1, 1 here also, 1, 1 here also. If you remember in the previous case, already highs was given to every flip flop, but here it is not the case. Here it is not the case. So what you have to do, this is the directly connected, but every stage input connected with the output of previous stage, all the outputs. Okay, now here all two outputs multiplied here, all the three outputs. If suppose one more stage connected here, then very good, you all are smart. Then definitely it is connected with the connected with the AND gate multiplication with Q3 and this one. disconnected. Is Q3, Q2, Q1, Q0. All the outputs will be multiplied, then will be input for the next stage. Okay, so that is the case for the synchronous counter. Now you can see the waveform. The first stage waveform is same as the previous one. At every clock, the output is toggling. At every clock, output is toggling 0 to 1, 1 to 0, 1 to 0. Okay. Now for this case, whenever this you are getting high here, then only it will toggle. Then only it will toggle. So high is here. When this is high to low, then it is toggling. When this is high to low, then it is toggling. Okay. You're getting my point. Okay. Same with the case of next. See here. For the next stage, when Q1, Q0 both are, Q1, Q0 both are high. See, this is both are high at this place, and Q1 both are high to low means falling edge. When both of the output falling edge, then only it is toggle. When both having high to low stage, then it toggles. Okay, then it toggles. Now next case. For Q3, when all three previous inputs means all three 1, 1, 1, and this is falling edge, this is falling edge, this is falling edge, then only it is toggling. This, sorry, this, then it is toggling 1 to 0. Okay, so that is the concept. Again, listen, the first output changes with the every clock, we are getting at every clock. Okay, at every clock. But for second, when previous was 1 to 0. Okay, previous 1 to 0. And now third, when both previous are 1 to 0. For fourth, when all previous outputs are 1 to 0 or having ones, then only it will toggle. Okay, so this is also 4-bit counter. If you can see, this is C 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Okay, and last will be 1, 1, 1, 1. So it is also 4-bit counter. I mean, that will count from 0 to 15. So the difference is of this clock only. Here clock is given at first stage, and output of clock is behave like a clock for next stage. But in synchronous counter, clock is given at the same time for each flip-flop. But here the JK flip-flop, DK flip-flop toggle or every high when both JK1. So therefore AND gates are required for this purpose. Okay, so all the previous outputs are multiplied by AND gate, then it is given as an input to the flip-flop. That is a synchronous counter. Okay, this is a pre-test exam, like pre-test MCQ, check your knowledge. Okay, so then procedure. Okay, I'll explain you directly the simulation. That post-test means you can check your knowledge, okay, how much you have learned after doing this experiment. Okay, so we'll do simulation. Okay, first of all, asynchronous counter. You know, we want 4 flip-flops. So these 1, 2 in one IC, 1, 2 in one IC. These are 4 flip-flops. Okay, so first of all, click on the switch. Okay, click on the switch. Now switch is on. Now the counting. For counting, this is the clock. So we have to provide clock from here. 1 clock, 2 clock, 3 clock, 4 clock, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Generate waveform. Sorry, 16. It is starting from 1, that's why 16. So see, when the clock 1, it was 0, 0, 0. Means all the LEDs were zeros. Okay, I'm again resetting it for explaining you. First switch is on. All the LEDs 0. When first clock, all LEDs 0. Second clock 0, 0, 0, 1. Only last LED on. Third clock 0, 0, 1, 0. Fourth clock 0, 0, 1, 1. Fifth clock 0, 1, 0, 0. Sixth clock 0, 1, 0, 1. 7, 0, 1, 1, 0. 8, 0, 1, 1. 9, 1, 0, 0. 1, 0, 0, 1. Like this. Okay. And you can generate the waveform here. So this is all about the asynchronous counter. Now next for synchronous counter. Okay. But here in the simulation, the circuit is same used here. Same IC will be used because 4 flip-flop are used, but difference is of AND gate. Here AND gates required. Okay. First is Q0 directly you get, but for second stage Q0 Q1 multiplied. For third stage Q1 Q1 Q0 Q1 Q2, all three are multiplied, and then we get the output. Okay, that is the circuit. Click on the switch. Now again, first clock 0, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perform is same. So this is all about synchronous asynchronous counter. If you really like it, please like and share. God bless you. Bye bye. Take care. We'll meet in the next lecture. Thank you. Bye bye.